Here we're looking through a hole in the window. Through this hole, sunlight is cast onto a prism. This prism projects a bright image onto a board, which has a hole in it. In this case, the hole is triangular. Through this triangular hole, the refracted light passes onto a projection screen, which is over here. And on this projection screen, we now have the rainbow-colored spectrum that Newton described. Our projection screen has a selective aperture in the form of a slit. At the moment, the spectrum covers the slit with its yellow part. Behind the slit, we have a second prism. As we can see here, the second prism is illuminated by the yellow light from the slit. Now producing on a second projection screen a multicolored image. It is actually rainbow colored, but it is brightest in its reddish, yellowish and greenish parts, where we recognize an elliptical shape representing the sun's disk. Now let me move the second prism sideways so we can see the whole disk. Now we see the solar disk as a whole. So the final image in Newton's experimental crucis is an image of the sun within the sky. The sky appears in the fainter colors, in this case blue, dark green and dark red. Now notice how quickly the sun moves, in this case to the right hand side and upwards. This is because the sun itself, of course, is moving. Motion of the sun causes the spectrum itself to move, and this of course causes different colors to pass the slit at different times. So we don't even have to move the first prism to select one color after another. There we can see the beautiful yellow part of the spectrum right now passing the slit. And behind the slit we don't see yellow, we don't see a single color, but we see a multicolored image which is mostly red, green, and also has a blue part to it. But now notice how the sun's disk has moved upward and further to the right. Notice also the red part, which represents the sky underneath the sun. Let me again move the second prism to the side so that we can see the whole disk of the sun. There it is. It is almost perfectly circular on this final projection screen. Now we see both images at the same time. On the right hand side, the spectrum, and in the upper left hand corner, the final image. At the moment, the prism is illuminated with a nice greenish blue. Let me move to the position of the final image in order to record what is seen from its place through the prism. Oh, wow. I see a nice blue tending toward the violet right now. And what do we see in the final image? Wow, we see a nice blue solar disk, but also some green and red parts representing the sky. That's amazing. Notice how quickly the sun has moved, and accordingly its spectrum also moved. We started with the red part, now it's already in the blue part. So let me go back to the first prism, move it a bit further away so we can see the initial projection. Hard to film. It's hard to film the initial projection because it's too close to the prism. But it's mostly white. Today there are tiny and soft clouds which cover the sky a little bit, so the sun isn't visible as distinctly as it used to be when there was a totally clear sky. So the image is a bit fuzzy, a bit blurry, but it's still recognizable as an ellipse. Alright, so as we can see, the final image on the second projection screen represents the outside world with the sun moving through the sky.